Hello, this is Peter from 1CNC UK, and what we're going to look at in this video are just a few of the reasons for upgrading your software package from Mill Advantage to Mill Professional. So let's get started. Using this model, we're going to concentrate on reducing both programming times and cycle times. There are a couple of features on this part there where we could use standard stock toolpaths, but there are also a few features that have tapered walls. So what we're going to look at is model toolpaths, specifically Z-level rough. For a boundary, I'm just going to use a stock profile which is exactly the same size as my billet. So the only places we're concentrating on are going to be these four corners and the closed pocket in the middle. Now, doing this in Advantage, we would need to extract the edges off all of the corner boundaries. We would need to extend those boundaries so that the tool center line is clearing the profile that we want to machine. And using traditional style toolpaths, there is no specific entry point. The software will calculate out its most efficient. So we would need to create 4 Z-level roughing cycles to remove the corners, and then we would need to use another Z-level rough to remove the pocket. Now when we come to simulate all of that, we're just going to open up the stock profile. I'm going to right hand mouse click, simulate rest as we normally do. We're going to pick a boundary, which is the only option available, as well as extents box in Advantage. We're going to give it the top of the job and the bottom of the job and select OK. We'll then select the profile and right hand mouse click. So as you can see, the tool is helicoiling in. It's then doing a full channel cut, which is obviously putting a lot of strain on the tool. And then it's going into machine the pocket, again helicoiling in, and opening up to size. So we've had to perform quite a few options to get the software to do what we want it to do. And this is where one of the big advantages of using Professional comes in. So we can turn off the Advantage profiles, and all we need in Expert is the main profile of the billet. Because the 4 edges of this part are identical to the boundary size, it will ignore these 4 options. So let's go into Z-level rough. We're going to use the same tool number, same speeds and feeds. We're going to give it the same clearance. As I say, when you come to use Professional, you have high speed open options and high speed closed. And again, just like in your stock toolpath area in Advantage, you do have rest machining capabilities. We're going to use an open boundary, and we're going to select next. At some point we are going to have to helical entry into the solid, so we are going to select ramp. We've got the same step over, the same depth of cut. We're going to leave stock on the sides. And one of the big advantages of Professional is this reducing step option. Because we're going down in large depths of cut, which is obviously the quickest way to remove the material, and we have tapered faces, you're going to end up with an awful surface finish to go over there with a finishing tool. Reducing steps gives you the option of starting from the bottom of the tool path and working its way back up to the top, and this will give you a semi-finished profile. Now these reducing steps can be as fine or as coarse as you like. I've just set it to 1 mil for speed. And we're going to select next. The boundary type is picked. We're going to allow the tool to start outside the boundary, top of the job and the bottom of the job, and then simply select finished. We then select the boundary and right hand mouse click. And there is our tool path. Now it might be you would prefer to do this pocketing cycle with a different size or a different style of tool. And one of the advantages, another advantage, is Expert comes with a full suite of surface and solid modelling options. So if we didn't want our Z-level roughing tool to machine this profile, I could put a cap surface on top of it. Again, I would need to extract the edge, so just for this example I'll open up the Advantage profiles. We're going to go into surfaces, we're going to create a surface from curves, we're then going to left click and then right click to end, and there you can see if I recalculated that tool path I could machine it without going into this pocket. I'm just going to remove that because obviously we are going to machine everything. Another thing I have in Professional is the ability to simulate to a stock model. Now a stock model is a fixture, setup, vice jaws, side stops, and that gives us again another advantage that we can simulate to our fixture and we can collision check everything. Now this is the only layer that must be called stock and must be in uppercase. So that particular layer does not need to be open when we go to simulate. One CNC looks inside the stock layer to simulate. And when we right hand mouse click and simulate rest, we now have the option for stock model and simply select OK. Now I'll just slow the simulation down and restart, and you'll notice the initial plunge or entry is a plunge. Even though I've selected helicoil, it knows there is no material where it's going to plunge in. It's not going to do any full profile cutting. It's going to just utilise full flute length, small radial cuts and high feed rates. So it's a far more efficient tool path utilising the entire flute length. We are running with collision detection, and as you can see we have an issue. Our retract clearance is not set high enough. So before I continue I will just put that right. So we're going to close the simulation down. I don't need to recalculate the entire tool path. I'm just going to go into my retract clearance and rapid clearance, and then when I reset we can simulate the part all the way through. Once it's finished the outside profile to depth, it will then come in and machine the pocket. It has been set to do Z level by entity, so it is working its way around in equal Z levels. You can restrict it to certain pockets. Once it reaches the same Z level as the main pocket, it'll produce that Z level. But as I say, we could put a cap surface on there and come in with another tool. because there is a radius in the bottom of this pocket, it is taking that into consideration, and as you can see now, all the tapered surfaces are now machined to model. And if we go to rest, you can see we've now got even stock all the way around the profile. So it's a very quick and efficient way of creating boundaries, and also very efficient toolpaths. Another high efficiency toolpath built into Mill Professional is flat area machining. Now, flat area machining is designed to machine multiple upstands, multiple profiles at varying Z depths. And it's very similar to how Z level roughing works. In this particular example, a single boundary which is the same size as my material block. So rather than an advantage having to select each surface on the top and machine them individually as either a pocket or a profile, one CNC Professional can do it in one boundary. I have already put a Z level roughing cycle down it just to save a bit of time, and as you can see, I've just used a single boundary again. The tool is working its way in between all of the upstands, and in this particular example I've gone down in 3 sensible pec depths. So let's have a look at creating our toolpath. Now we need to know the top of the profile and the bottom of the profile. So if I just want to machine the upstands, I can go into verify, and the tallest one is at 0, the lowest one is at -40, or if I wanted to machine all the way down to the plateau at the bottom, it would be at -50. For this example, we'll just machine the top of the bosses. So we're going to go to flat area machining. I'm quite happy with the 10mm end mill, quite happy with the clearances. We're an open boundary. I'm quite happy plunging because I'm telling the tool to start outside the boundary. I've only got quite a shallow depth of cut to do, so I'm quite happy with 60-70%. The boundary is a picked boundary. I'm starting outside the boundary, and as I say, if we want to machine this top surface, I need to start looking above 0. Now any figure above 0 will be fine. I've just left it at +1 mil. If I want to machine the bottom plateau, I would look below 50, so I would go to -51. But as I say, in this example, we're just going to machine the upstands, so -41. We can then select the boundary and right hand mouse click, and there we have all of the top faces machined. Now again, just to save a little bit of time on the length of the video, rather than run the Z level roughing cycle, I've created a stock model, and the stock model is just basically the same model, but these upstands have got 0.1 of a mil on them, so you can see that they're being machined. So I can miss out the Z level roughing. I'm going to go straight into simulate. I'm going to simulate to a stock model and select OK. And you'll see, just with the use of one boundary, the tool is machining the top face on all the bosses. And as I say, if I told it to machine down to 50 mil, it would machine all the profiles as well. So a very quick and very efficient toolpath. As we've already mentioned in the previous video, One CNC has a full suite of solid and surfacing options. So let me just show you how quick and easy it is to start creating solid models. And then what we'll do using Pages is turn this solid model into a 2D print. So we'll just start off with a simple rectangle. I'm just going to accept world coordinates 0, 0. We'll give it a length of 115 and a height of minus 90 and select OK. We'll put a couple of fillets on the corners, so we'll go with the 20mm fillet. I'm quite happy with that. And we'll put a couple of holes in there, and we'll just grid snap these so they're arc center. And what we'll do now is turn this into a solid. So we're going to go to our extrude options. We're going to extrude curves, and we're just going to select the profiles that we want to extrude. As these holes are going to go through this boss, I'm quite happy selecting all. And then we're going to give it a height of minus 30. And just to finish it off, we'll put a chamfer on the front edge. So back into my model tools, fillet, we'll go with a chamfer of say 18mm and just left click on the front edge. So that's a very quick and simple example of how we can obviously create solid models. We're now going to launch pages. Now the first thing we need to do is add a page. So when we left click on there, these are all the templates built in to one CNC. I'm just going to use the ANSI B and select OK. And then it's a question of selecting the views. So go with the top view first of all. It'll give us a preview. We're going to add that to screen, and I'm just going to left click on the top corner. We'll go with the front view next. Again, we'll get a preview. We're going to add this to page, and you'll see how easy it is to line all these drawings up together. We can snap to that, and we'll do a default view, and this time we'll do this one as a model. We'll do an isometric view and a model, and simply add that to page and close. Now you can move from drawing space to model space very easily just by using these two arrows. So I'm now going to go back into my model space, and let's say we're going to modify this part. So let's just put a couple of chamfers on this hole. So we're going to go back into fillet. We're going to just use a chamfer. We'll swap this over to 2mm, and we'll just left click on the top and the bottom of these holes and right click to end. So we're going to return back to our drawing page. We're going to relaunch pages. What we want to do now is update this page. So we're simply going to update the page, and you'll notice straight away all of the views have been modified. So let's give this one a right hand view as well. We'll turn this back to wireframe and we'll add to page. So now we can obviously start putting our dimensions on there. So we'll start off with a couple of horizontal ones. Just drop over and do a quick vertical. We'll do a radius, maybe a diameter, and let's do an angle. Well, I want to reference it to this vertical edge here, so I'm just going to draw myself a line. Then when we go back into our angle dimension, we can obviously create the angle. Now, as well as obviously doing dimensions, we can obviously tolerance these dimensions. So we'll just go into edit, left click on the one we want to add a tolerance to, and we'll work on a plus or minus tolerance with this one, and just give it maybe 0.05 above and below, and you can obviously see that you can dimension all of these. We'll just do one more. We'll go with the leader arrow this time, and we'll put some text in. So I'm just going to left click, and we'll just say in the text box 2 mil by 45, 4 places, and select OK. You can obviously modify any of these boxes and resave them, but there we have it. A very quick and simple way of creating solid models and then creating 2D drawings. I hope you found this video interesting. If there are any questions at all, please contact us at onecsc.uk. Have a good day. Bye bye.